Students, I am discussing about design of progressive presstool in this session. We want to produce this sheet metal component for which we are going to design a progressive presstool. So this isometric view shows the progressive presstool that has been designed for producing this sheet metal component in mass quantities. The raw material for producing this sheet metal product is a lengthy strip. We call this as feed strip. So this feed strip we have to feed into the progressive tool, and out of this feed strip we are going to produce the sheet metal component to the required shape and size. The exploded view of the progressive press tool is shown in this figure. We have to purchase a die set from the market. So this die set is commercially available in the market, and we have to choose a proper size of the die set, and we have to build all other parts of the progressive tool, and we have to mount it on the top die shoe and bottom die shoe as shown in this figure. So this is the bottom die shoe, this is the top die shoe. So this can be purchased from the market. The top and bottom die shoe are moving relative to each other using a guide post and guide post. So if you see this, there is a guide post and guide post. So this maintain proper relative movement between the two parts. So the top die shoe moves up and down. So this is the press we can make use of for cutting the sheet metal product out of the feed strip. So in this press there is a ram. So the ram is moving up and down. So one down movement and up movement is a stroke. It's called as a stroke. So depending upon the number of strokes, the productivity of the sheet metal product increases. If the press ram is able to work at a stroke speed of 60 per minute, then we can able to produce 60 number of sheet metal product per minute. So over the bottom die shoe, a die plate is placed. So die plate is having cutting edges on it, and it has to be produced out of a harder material, and it has got the cutting edges. Over the die plate we place front gauge and back gauge. Over the two gauges we place the stripper plate. So these are the elements that are going to be mounted on the bottom die shoe. On the top die shoe we are going to mount the piercing punches, 2 in number. These two piercing punches, smaller in size, cannot be directly mounted to the top die shoe. So we first hold these two piercing punches onto a punch plate. This is the punch plate. This punch plate in turn can be mounted onto the bottom surface of the top die shoe. Coming to the blanking punch, this is the blanking punch. It has larger area. It has got a collar. It can be directly mounted onto the top die shoe. There are two pilot which are going to be mounted on the blanking punch for the purpose of guiding the feed strip in the second stage and onwards. The feed strip, after cutting out the first sheet metal product, will look like this. So the first product has been cut out from the feed strip, and this is the condition of the feed strip at the end of the second stroke of the press. Let us see what are the sequence of operation to be carried out to get the required shape of the sheet metal. Now the shown here is the die plate. The die plate has got piercing die opening and blanking die opening. Now these are the two piercing punches, and this is the blanking punch. So these three members will be fitted onto the top die shoe, and the top die shoe is moving up and down due to the working of the ram of the press. The punches will hit on the feed strip, which is going to be kept over the die plate. So before the first stroke is initiated, we have to keep the feed strip. This is the feed strip. The feed strip is the raw material for making the sheet metal product. The feed strip is placed up to this point. The feed strip is in the form of a roll, continuous roll, or it can be in the form of long strips. So the feed strip is placed up to this point, okay, before the first stroke of the press is initiated. When the punches are coming down, it is hitting on the feed strip, and at the end of the first stroke, you can see two holes have been pierced on the feed strip. The piece which is falling through the die opening are waste. So this is the condition of the feed strip at the end of the first stroke. Before the second stroke is initiated, we have to move the feed strip up to this point. So we have to advance the feed strip by a certain distance called feed step. So we are advancing the feed strip by an amount called feed step. Okay, so now this is the condition of the feed strip before the beginning of the second stroke. So during the second stroke, both the blanking punch and piercing punches will be hitting on the feed strip, and it will create a blank. Okay, it will blank the sheet metal out of the feed strip, and the piece which is falling through the blanking die opening is useful. So this is what we want as a sheet metal product. The piece which is falling through the piercing die opening are waste. So this is the condition of the feed strip at the end of the second stroke. From the second stroke onwards, for every stroke of the ram, you get one workpiece. So this figure shows the die plate. Over the die plate, a front cage is placed, and the back side a back cage is placed, and the back cage is longer than the length of the die plate because it has to support the feed strip. So when you place front cage and back cage over the die plate, a channel is created, and this channel is used to feed the feed strip. So these are the two piercing punches which are held on a punch plate. The punch plate will be in turn mounted to the top die shoe. So this is the blanking punch which is having a collar. The collar is provided with threaded hole for fastening it with the top die shoe. So stripper plate is placed over the two gauges, front gauge and back gauge. Over the front gauge and back gauge, a stripper plate is placed. So this is another member to be added onto the press tool. So the stripper plate is one of the important member. The function of the stripper plate is to strip out the feed strip during the upward movement of the punches. So you think of the punches going through the opening on the stripper plate. So there are two punches, piercing punches and blanking punch will move through the feed strip, move through the stripper plate, and it will hit on the feed strip. Upon hitting on the feed strip, it will cut the required shape, and when it is moving up, when the punches are moving up, the feed strip will try to move along with the punches. To remove the feed strip out of the punches, we have a stripper plate. So the stripper plate will strip out the feed strip from the punches. So that is the function of the stripper plate in a progressive tool. Now let us discuss how the cutting action is taking place in a progressive tool. So shown here is piercing punch and piercing die. We have to keep the feed strip in between the punches and the die. This is the feed strip which is placed over the die plate. If you look at the sectional view, the punch and die have got a small difference in size. So in the case of a piercing, the punch is made to the size of the drawing and the die is made bigger by an amount called die clearance. So the die clearance is the difference in size between punch and die of a stage. So now what happens during the cutting action? When the punch is coming downwards due to the movement of the ram of the press, first it is hitting on the feed strip. Further downward movement of the punch will apply a force on the feed strip. When the applied force is exceeding the shear strength of the feed strip material, then cracks starts initiating on the feed strip. That is what is shown in this figure. The cracks start originating from both the top surface and bottom surface of the feed strip, as shown in this figure. Further downward movement of the punch will make the cracks to join together like this. So the cracks originating from the top surface and the cracks originating from the bottom surface of the feed strip, both the cracks are joining together. At this stage, the piece is separated from the feed strip and it is falling through the opening on the die plate. So this is how the cutting action is taking place in a progressive press tool. So the cutting action is taking place due to shearing action. So the die clearance is the clearance which is maintained around the punches. So this is the difference in size between punch and die member of a press tool. So die clearance is taken as 20% of the sheet metal thickness for this example. So this is what you want to produce out of the progressive tool. The sheet metal is having a thickness, this sheet metal product is having a thickness of 2 mm. It is made out of brass and these are the two holes which are having a size of 6 mm, and we have to make an outer contour as per this dimension. 36 is the width and the radius of the curvature is 18 and the center to center distance is 40. So this is what we want to produce out of the progressive tool which we are designing now. So since the sheet metal product is having a thickness of 2 mm, 20% of 2 mm is 0.4 mm. So for our example, we are maintaining a die clearance of 0.4 mm. So once the die clearances are arrived, we can determine the size of the punch and die. For the piercing operation, the punch size conform to the drawing size of the hole. So as per drawing, the holes are having a size of 6 mm. So the piercing punches are having a size of 6 mm. Now the die clearance of 0.4 is applied to the die. So the die opening is having a size of 6 plus 0.4, 6.4 mm diameter. For the blanking stage, the blanking die opening conforms to the drawing size. So the drawing size is 40 is the center to center distance and 36 is the width of the sheet metal component. So we are maintaining the drawing size to the die member of a blanking stage. Then punch size is made smaller by die clearance of 0.4 mm. So this is the punch size. This is the punch size for this design. See here the width is 35.6. After subtracting the die clearance of 0.4 mm from the drawing size, the width of the blanking punch is arrived as 35.6. The center to center is 40 and the radius is 18 minus 0.2, half of the die clearance. So 17.8 is the radius of the blanking punch. The next step in the design process is to lay out the scrap strip. See, once the required number of pieces are cut out from the feed strip, then the feed strip is no longer useful because we have removed the sheet metal product out of the feed strip. So then it is called scrap strip. So shown here is the feed strip at the end of the second stroke. So this is we are calling this as the scrap strip. Okay, once the required number of pieces have been cut out, then this strip becomes scrap strip. So first you have to design the scrap strip layout as a next process in the design process. So on the scrap strip layout, we have to first arrive at the margin. So here in the piercing stage, we create two holes. In the blanking stage, we cut the outer contour of the sheet metal. Even though we don't do the cutting of outer contour in the first stage, we draw the dotted line of the blanked contour for the purpose of arriving at the dimensions. The margin is the space between the die contour and the edge of the feed strip. The margin for our example is taken as 2 times thickness. So 2 into 2 is the 4 mm. So thickness of the feed strip is 2 mm. So 2 into 2 is 4 mm. So since we want to produce sheet metal component of thickness 2 mm, we have to use a feed strip of same thickness of 2 mm. Out of the same material, we have to make use of the feed strip. So the material is brass. So we have to use a feed strip of thickness 2 mm, which is made out of brass. So the margin 4 mm is maintained on all 4 sides. So these are the other dimensions we have to arrive on the scrap strip layout. What is the distance between center of the center of the piercing die opening and center of the axis of the curvature on the blanking die? So this distance we have to find out. So this distance can be easily arrived. So what is the distance between this center to this arc? It is 18 mm as per drawing. 18 plus margin is 4. So 18 plus 4 from again the distance. Okay, from the dotted line to the center again 18. So 18 plus 4 plus 18. So that comes to 40. So 40 is the required distance. Once we arrive at this distance, then we can also find out this feed step. As I already told you, feed step is the distance by which we have to advance the feed strip for every downward stroke of the press. So this distance is 40 mm. From here to here, off of the center to center distance, it is 40. 40 is the center to center distance on the component. Off of that distance is 20. So this is 20 and again this is 20. So when you add 20 plus 40 plus 20, you get the feed strip as 80 mm. Then what is the width of the feed strip which you have to use? So this distance is 36 as per drawing. Then we are maintaining a margin of 4 mm here and here. So 4 plus 36 plus 4. So we have to use a feed strip of width 44 mm for our design. The next step in the design process is to design the die plate. So the die plate is placed over the bottom die shoe. It has got the cutting edges on its surface. If you look at the sectional elevation of the die plate, you have got uniform size only up to a certain depth. That is called land. After that, you have got a relief. In order to facilitate easy falling of the pieces which are cut out of the feed strip, we are maintaining a relief. So the straight portion is called land. So this distance is arrived from the scrap strip layout. This 40 what we arrive from the scrap strip layout is maintained here, and this 40 is the center to center distance between the two holes on the component. Again this 40 is the center to center distance. So all the dimensions have been arrived from the previous steps. So the die plate should be manufactured out of a material which can be hardened. So high carbon high chromium steel is one of the example for making the die plate. You have to harden to a level of 58 to 60 HRC, then you have to grind it. This is the stripper plate. The stripper plate is placed over the two gauges. These two gauges are kept over the die plate. So we maintain the dimensions of the stripper plate same as that of the die plate. And one more dimension we have to arrive is 95. So 95 is the width of the die plate. So with this 95 is arrived after considering the width of the back gauge and front gauge. So we are going to use a front gauge and a back gauge of width 25 mm for this example. So in that case, we have to maintain a size of 95 mm as the width of the die plate. As I already told you, the punches, piercing punches are smaller in sizes. That cannot be directly mounted to the top die shoe. So first you have to fit the punches, piercing punches onto the die plate, so onto the punch plate. This punch plate is in turn mounted onto the top die shoe. So look at the exploded view. This is the punch plate. So this punch plate has got opening to fit the two piercing punches. This punch plate in turn will have the necessary threaded hole to fasten this punch plate over to the top die shoe. So we have to design pilot. The pilot are going to be mounted over to the blanking punch in order to guide the feed strip during its second stage movement. So this pilot we are going to use 2 in number. This pilot is going to engage with the hole already pierced during the piercing stage. The hole diameter is 6 mm. So we are using a pilot of diameter 5.9, leaving a small clearance of 0.1 mm. So this is the sectional view of the designed progressive tool. This is the sectional elevation. This is the side view. If you refer to the reference book, Die Design Fundamentals by J.R. Paquin, the sectional view is given in the form of a printed drawing. So this is the sectional elevation of the designed progressive tool. It shows all the components, including the pilots. This is the sectional side view of the progressive tool. Either you can make use of this printed drawing or this handwritten drawing for your reference.